Let's now see how to draw the perpendicular bisector of a given line segment. Let's say we are given line segment AB and we need to draw perpendicular bisector. How do you draw it? Take a compass, take a distance in the compass more than half of AB. Why more than half of AB? Let's try taking less than half of AB. You already know the construction, right? Now we are trying to understand all the logic. So let's understand the logic for everything. Why more than half? Let's try taking less than half. Draw an arc, move the leg of the compass to the other side, draw an arc again. What do you see? The two arcs never intersect, correct? The two arcs never intersect with each other. We need them to intersect, only then we'll get the point from which we need to draw the perpendicular bisector. Hence, you'll always see that the distance needs to be more than half of AB, or more than half the distance between the 2 points from where you're going to draw an arc. The logic is simply because sum of two sides of the triangle has to be greater than third. That's actually the logic behind this. We take a length more than half of AB, draw an arc on top as well as the bottom, because we need to draw a perpendicular bisector, right? It's a line. To draw a line, you require 2 points, right? Why not just one arc? Why two arcs? That's the question you should ask. No, now we are going to understand. I told you we're going to understand the logic of the constructions, right? So don't blindly follow any instruction. Always ask why. Why two arcs? The reason is we need 2 points to draw a line, right? If we have only 1 point, an infinite number of lines can pass through. Hence 2 arcs to get 2 points so that we can draw one unique line. Now move the point of the compass to B. Move the leg of the compass to point B. Again draw 2 arcs, one on the top, one below. Now you have 2 points. Join the 2 points. This line passing through these 2 points is going to be the perpendicular bisector of segment AB. We can call these P and Q and this point as M. Why is this the perpendicular bisector? Visually, as usual, let's first understand visually. What are we going to do? Put this on a piece of paper. Put this on a piece of transparent paper and then fold it. When you fold it along the perpendicular bisector, you will see that AM and BM coincide perfectly with each other. Correct? That's why this is the perpendicular bisector. What does perpendicular bisector mean? There are two things to it, right? There are two things to it. One, let's open it up. One, that these two sides are equal. AM and MB are equal. Bisector, right? Divides it into two equal parts. And this angle should be 90 degrees. Correct? Angle PMB as well as angle PMA should be 90 degrees. Those are the two things that perpendicular bisector means, right? Two words, perpendicular and bisector. So we are going to prove both of these things. Let's try and prove both of these things. How do we start proving? We need to get triangles, because everything is going to be proved using congruency. So we first need to get triangles. How do you get triangles? We said we'll join all of the points that we constructed. That's how we are going to get triangles. So let's join A and P, B and P, A and Q, B and Q. We'll join these 4 points. These were the 4 constructions we did. Look at these two triangles now. Look at these two triangles, PAQ and PBQ. They are congruent. Why? SSS test. Always start with the SSS test, right? I didn't lie to you. What I promised, you will see that in every step. So why SSS test? These two are equal. PA and PB are equal. The reason is we kept the compass here, took the same length and drew the arcs, correct? That's why. Similarly, QA and QB are equal. Again, same reason. The arcs drawn from both sides had the same length. This side PQ is anyway common to the two. That's why these two triangles are common. Again, the same thing. You'll see always while folding, they'll perfectly overlap with each other, right? So if you open, these two triangles are congruent. If these two triangles are congruent, these two angles on top, angle APM and angle BPM, these two angles are equal. These two angles are equal. Otherwise, this triangle didn't help us, right? What we had to prove was all on this line, which anyway got hidden within the triangle. You need to there are two things that you prove, right? You need to prove. It's perpendicular and it's a bisector. So we need 2 steps. In the previous case, just one SSS test gave us the answer when we had to prove an angle bisector. Here, we need 2 steps because there are 2 things to prove. So from the first step, we got the fact that these 2 angles are equal. Now, let's look at 2 different triangles. Let's look at this triangle and this triangle. These should be the more important triangles, right? Because everything we want to prove, you'll see, is marked on these 2 triangles. What are the 2 things we need to prove? These 2 sides are equal. AM is equal to MP and these 2 angles are 90. If one of them is 90, obviously the other one will be 90, correct? Because the total is 180. So that's what we need to prove. Hence, these 2 triangles. First we took the full triangle, now we are taking half the triangle. Are these two triangles congruent? Yes, again. Why? This time it is SAS test. This side is equal to this side. Same distance because same length of arc. This is a common side, so this side is equal, and this angle we just proved that these two angles are equal, correct? That's why you have SAS test. So these two triangles are congruent by the SAS test. These two triangles are congruent, automatically AM will be equal to MB, CPCT. Similarly, angle PMA will be equal to angle PMB. These two angles will also be equal. Sum of these two angles is 180 degrees because they are a linear pair, so each of them will be 90 degrees. We've proved everything. We have to prove two things, right? It's perpendicular. We proved these two angles are 90. That means it's perpendicular. Bisector. We proved AM equal to MB. So it's a bisector. Correct? So two things to prove, two steps. First, the big triangle and SSS test. Then the smaller triangles and SAS test. That's how you prove that this is indeed a perpendicular bisector of this line segment.